kilonewton per meter square. So ideally, it's better to adopt the higher value. In this case, it's better to adopt 2 kilonewton per meter square as your life load, that is variable action. Okay, so once you are done with this, the next you're going to do, which is our 7, is to calculate. Okay, you calculate for the ultimate. You calculate for the ultimate design load. Okay, you calculate for your ultimate design load. All right, and for our slab, we usually consider it as a simply supported, okay, with a uniformly distributed load, because we are treating the panels. Now understand that as you're treating the panels, your emphasis should be at the shorter side, because that is where the main bar is expected to run. Okay, the bottom bar is expected to run across the shorter span. So your emphasis of designing is to design for the tensile reinforcement, and your bottom bars are mainly for tensile forces. Okay, so for you to calculate your design load according to Hero code, we have it as W is equal to 1.35 GK, okay, plus 1.5 QK. All right, and I have told you previously that your GK is your dead load. Okay, is your dead load, the summation of this. All right, because these are permanent load on that on that slab, so that becomes your GK, the summation of all of this. Then your QKs, if you are adopting 2, so it becomes 2 here. So when you work out this, that becomes your ultimate design load. All right, so you take note of that. So once you are done with that, the next you're going to do is to determine the design moment. Okay, you determine the design moment. All right, because you have to look out for the moment that is generated on that slab unit. Okay, so for you to determine the moment in this context, we can adopt M as equal to WL square over 8. Okay, so this becomes the moment, the maximum moment, because we are looking at the maximum moment that will be generated at that short span. Okay, because our emphasis is mainly on the short span. So the maximum moment there is WL square over 8. Now our W is what we calculated as our ultimate design load, while our L becomes the span. Okay.